My name is Duarte Vergara. I've been working with under the mentorship of Dr. Siddharth Pandey with a team looking at terrestrial analogs in Ladakh, India. My talk for today is called Terrestrial Analogs: Clues for Mars Past Life on Ancient Lakes. So first off, I want you to look at these two pictures, Earth and Mars. And at first sight, one can say that there's not much similarities between the two, but that could be because maybe we're not looking at the right time. What I mean, what if we take Mars on a travel back time to 3 billion years ago? We will have something like this. So that's a huge difference, right? If we look closely, we have places on Mars today that look like this. This is the AG0 crater on Mars, but 3 billion years ago, it could have looked something like this. And there are places today on Earth that have similarities on the environmental conditions as this Noachian epoch Mars. Today, I will be talking, as I said, about Ladakh, India, which is located right there on the Trans-Himalayan region. It's a high altitude site with valleys at 3,000 meters above sea level and mountains well above 6,000 meters above sea level. That gives it a lot of UV radiation and also freezing temperatures, going as below as minus 40 degrees Celsius at some points. Also, it's located in the rain shadow of the Himalayas. That means that gets little to no precipitation, which helps a lot on the preservation of the landscape. More specifically, I want to talk about Sokar, Lake Sokar, which is a high altitude saline lake. Its basin is at 4,500 meters above sea level. Uh, its ground has permafrost, which means that the ground is frozen the whole year round, and also it has over two, sorry, 20,000 years of Paleolithocene deposits. As you can see here on the map on the left, Sokar was much bigger than what it is right now. I don't know if you can see this pointer. Yeah. This is Sokar right now, and this outline here is Sokar in its maximum extent. The yellow line here is the water catchment. That means that any water that is inside this line goes to this basin. So now here on the right, you can see Sokar as of today, and it has some features drawn, but more importantly is these shorelines that shows the regulation of the lake, and the highest one at almost 100 meters above the current level. So the thing is that it has shrunk a lot, and that's exposes most of the sedimentary record that this lake has in his history. And those records are readable, like pages in a book. So you got a lake, and it's, their sedimentation process goes on putting layer by layer of sediment. And then those sediments can tell you a lot of information about the time they were deposited. Also, they can have biosignatures as plant or algal remains, even pollen or leaves. It can have calcareous fossils like ostracods shells, also remains made of chitin like zooplankton, and it can tell you about the environmental conditions where they were deposited. So to give you an example, if I take a core of these sediments and I see it, and in some part there's like really fine mud, silty mud, you can say that it was in an environment of deep waters where there's a low energy in the system, everything is stable. But you find sand with rock chips or different grain sizes, you can say maybe it's something well, from fuel origin with more energy in the system, or if you had carbonates, you can say that the lake was shallowing and the evaporation was higher, so there were more precipitation of carbonates. Also, as you can see here in this picture, there is the exposure segments of the lake, a lot of different layers, and here you have some plant remains, and here also you have a real core of the Socar Lake with different sediments also. But now we get that we can have some biosignatures here on these sediments, but what what factor is important to the preservation of these biosignatures? Because nothing tells you that they will last for thousands of years because organic matter degrades. But that's when permafrost is the key to this preservation. As I've said, Socar presents permafrost, which is soil that keeps uh, freezing through the whole year. It has an empty layer that unfreezes and freezes seasonally, but below this level, all of it is freeze for continuous time. So that's what all of this organic matter preserved for us to find even thousands years before the time they were put there. Also, you have here an up-close photo of lake sediments with ice segregated in the permafrost of Socar. And we know that processes that like this permafrost happens also on Mars. So we have the idea that maybe in the permafrost of Mars, there's also organic biosignatures of organic remains waiting there to be discovered. So we got sites like this right here on Earth, and we can use them to train. Terrestrial analogs can serve us as training camps here on Earth. Every analysis, every observation, test, or identification of a life form or their presence at some point in time can give us the correct methodology to say, yeah, this works and this thing doesn't work. And having that trial and error right here on Earth is a really important asset to missions on Mars, even rovers or at some point humans. So we know what to do in the correct way, the correct methodology at some to some point say, hey, here are biosignatures, and we have evidence of past life in Mars. We can make the trial and error here so we don't screw it up on the surface of another planet. To close my talk, I want to say that as much as I like Mars exploration and all of the different mysteries that are there waiting for us, I think that we also need to focus on Earth preservation. Because what if most of the key to the answers to all of those these mysteries on another planet are right here with us at the reach of our hands. And if we don't take action and preserve them, we might lose them. So the better we understand our own processes here on Earth, the better resources we have to uncover and understand mysteries on the surface of another planet. So that would be my talk. Thank you so much for listening. Also, I want to talk a huge thank to my mentor, Dr. Siddharth Pandey, and my teammates, Tanmaya, Lisbeth, and Shayla, for all the work put in these 3 months. It's been really a pleasure working with them. Also, thanks, Raham. Thanks, Sanjay, for the opportunity.
Fantastical, awesome talk. I love your message at the end. Bringing space down to Earth is one of the most important things about what we all do. We do have some time for a question or two if anyone in the audience wants to type in the chat or raise your hand and I can call on you. Sanjay has his hand up.
Aaron, thank you for your presentation. Actually, for a change, is not a question, but a comment. I
Thank
completely echo with your message. One of the greatest discoveries we've made by going to the moon and exploring space has always been, to my mind, looking back at Earth and realizing how fragile it is, how lucky we are to live on such a planet, how important it is to preserve it. So thank you for mentioning that. You're the first today to do so, and I'm just grateful. So keep sharing that message. It's a very powerful one.
Thanks.